Okay, final update on the front panel now. I had the display working and now I have the switches working. So the way that the switches work is that each switch is connected to a bit of one of the HC595s, and they're all tied together to pin 5 of the Arduino. So if I press on any switch, it connects pin 5 to one of the bits on the 595. And pin 5 has the internal pull-up. So if I get a low signal on one of the switches, it'll say that switch is pressed. So what I do is I set all the bits to 1, and then if I push the switch, nothing happens. And then one by one, I'll set one of the bits to 0. So if I press the switch and I get a 0 on the output, I know that I've pressed that switch, and I take those zeros and I move them across from 0 to 7 in the data, and so I'm doing a scanning of the switch matrix. So if I push the button, it says left, up, down, right. The middle button is enter, and then I'm not sure what to do with these yet, so I just labeled them 1, 2, 3. But yeah, it works great. I'll show you the code a little bit later. Yeah, I'm very happy now. So I have a way to talk to the switches, and I have a way to display the data. So I have input and output, and then I have a whole bunch of unused pins in the Arduino to control things on the inside of the box. So we'll have to figure out what type of projects that I want to put on the inside, but I have a very nice display now, very nice front panel for the for my projects. Okay, here's my program. I'm not going to claim it's the best program, but it's a program. And this is to run the front panel. So we have a 3 lines to run the 595, clock and data, and a latch. So you clock the data into the part, and then when you hit the latch, then the output changes state. Then I have the input pin for the switches, pin 5. There's that internal LED on the Arduino if you want to turn that on and off for debugging. I've used that before. Bits, you'll see how I use that, and switch selected. So when you push the switch, it gives you back a number of which switch you've pressed, and so that's what that is. Now you'll notice that the address lines on the data output are reversed. So A0 through A4 goes from D0 through D4. So it's backwards. So this little trick here is so that if I say 3, then this will output 2 or 1, 0, 1, 2. So anyway, it does it backwards. You can figure that out, but it flips these 3 bits. I'm using the A0, A1, and A2 to address which one of the 8 LED segments or display characters that I'm talking to, and they're in reverse order. So this is just a trick to put them back into the correct order. And then I have some messages, 8-bit messages, or 8-character messages, I'm sorry. IMSAI guy, left, right, up, down. So, okay. So, the next thing we're going to do is make the I/O lines either outputs or inputs. So I have a bunch of outputs, and then I have one input, and I'm going to turn on the pull-up resistor on that one particular input. Then I'm going to set some initial states. So the latch pin is low, the data pin is low, clock pin's high, LED is low. Okay, then we're going to reset the display, which is just toggling the reset line. So you can see here we're going to clock some data, latch it, and then clock some data and latch it. So we're going to clock this bit stream, and then we're going to clock this bit stream. So you can see that this particular bit was low, and then it goes high. So this just does a reset. And the way that the two 595 chips work is that these um, commands, shift out does 8 bits. So the two serial devices, these 595s, are daisy chained together. So when you shift in one data, it goes into the first register. Then if you shift in another bit, what was ever in the first one gets shifted over into the second one. So you have to do a double shift to get the data into all 16 bits. So that's why there's two shift outs for every latch. Okay, and then we're going to read the switches, and then depending on which value comes back, we're going to display message 0, 1, 2, 3, 4, 5, 6, 7. So that's the way that works, and that is in our loop. So this gets executed round and round and round. Okay, so here's some routines. I have a routine called update shift register. Um, and see, am I actually using that? I guess I am. Yeah, I am using that. Okay, so it's going to, oh, I remember how this works now. I'm sorry. Um, so the bits, we are going to set some high and some low, and then we're going to OR in some other things. So remember we have the address, the A0, A1, A2. We need to get that into this bit stream. And the way we're going to do that is we're going to OR it in. Okay? So these are the 3 bits. They're set to 0 initially, and then whatever value address has, um, we're going to shift that over 2 places. So it'll match these 3 bits, and then we're going to OR it in. So that's the way that works. Then we're going to shift it out and latch it, shift it out and latch it. And so the two shift and latches are the right pin's going to go low, and then the right pin's going to go high. So we're going to execute a write. So we're going to clock in data and do a write. Clock in data, do a write. So, and then we have a serial latch, because I'm using it over and over again, this serial latch thing. And that just takes the latch pin and sets it high and then sets it low, and that does the latch. So normally it sets low, and then we're going to go high and then put it back. So on the rising edge is when the 595 gets latched. Then we're going to display a string. We're going to have a 8-bit character string. And so we're going to go from 0 to 7. And we're going to then take each character of the message, 0 through 7, and each of the address lines. Remember, we're going to have to do that flip bit thing for A0 through A2. So we're going to do flip bits on J. So that's the way that works. Then we're going to the very first video I showed you, I was displaying the fonts. So this is a leftover from the first program. This just displays 0 through 7F and goes around and around and around. So that's just a kind of a test debug thing. And then here's our read switches command that we've just added. We're going to set a default value of switch selected as 9. So if you see 9, it means that no button has been pressed. And then if you press a button, it'll come out either 0 through 7. We're going to go through 7 cases, or 8 cases, 0 through 7. We're going to start with bits FF. So that means that all the data lines are high. And then one by one, we're going to do a bit clear. So we're going to set one of those bits to 0. And then we're going to then shift that out. And we're going to latch it. And then we will then check the state of pin 5, which is the switches. And we will then save that value in switch state. Um, if switch state is low, which means a switch has been pressed. If it's high, unless the switch has been pressed. If the switch was pressed, then we're going to do switch selected is going to be I. So whichever part of the loop we're in, we're going to save that as the switch selected, and then we're going to break out of the for loop, and that's it. So that's our program. As good or as messy as you like to think it is, it does work. So happy with it, and I now have a working front panel. So.